is a very used and convenient. So there are a lot of consumables, recommended part numbers for various GC application purpose like vials, syringes, septas, ferrules, gold seal, liners, column nuts, detectors, and all are available. If most of the general purpose for application specific, yes, we can discuss and further. So in a overall, the integrity of our analysis or the results is based on the starting from inlet, that is vial, syringe, after that septa, gold seal, liner, of course the detector elements, flow meter gas flow and the gas quality, and the column, and how we connect the column to that one also influences, and then the ferrule cleanliness, and the gas filters will help us to purify the gas to not to have any problems. And this all together will provide a good result for our GC analysis. With this, thank you very much. Tejas, if any questions are there, please feel free to type in your chat box so that I can answer.
Okay, thank you, Ram. Thank you for this very informative presentation regarding the GC supplies and columns. To let us know that how even small parts can make a difference in our analysis and can help us get the reliable and the reproducible results. So we have questions. So I'll start with the questions. Are you ready?
Yes.
Okay. First question is, so what is the importance of the liner in the GC analysis and how do we choose our liners?
Liner is a very important part of our GC analysis actually. As we discussed, cleanliness or inertness of the liner is a very important thing to get a good result first of all. Because any active surfaces in the liner will give a very bad pitch shapes, especially evidentially when you see some of the applications where polar analytes, if you are doing it, and highly polar analyte analysis, you see that clearly peak tailing or a peak shape is not good at all. So those cases, we need to have a very good liner with the inertness, and then whether glass wool is required or not required. As we discussed during the session, glass wool is required for the samples which are extracted from the natural sources or the matrix is more influencing, then a liner is recommendable. If there is no matrix influence much in our sample, it's like an API product or standards, you don't require a liner at all. Especially for active compound analysis, if there is no matrix influence, try to use without a liner. So it will give a good peak shapes and then good sensitivity.
Okay, thank you, Ram. Another question is, for a GC flow meter, there are no connectors provided. Probably they want to know, do we have the connectors for the GC flow meter?
Yes. Connectors are actually not provided with the GC flow meter is because there are different connectors will be available for a different purposes. So that is where you can choose the connector based on the purpose what you made it. For an inlet or the detector, when inlet and vent, more or less you use the same connector, but the detector is different. That is the reason, and type of the detector also makes it. So it is an NPD, it is a different connector, you require a FID different connector, and that is the reason, based on the usage of that user, they can choose that connector. If we add in the bundle, it will go for a cost. That is the reason we separated it out. Yes, you can reach out to our sales account managers so they can help you out and give a connector which you require for the purpose what you are looking for.
Okay,
Yes,
thank you, ma'am. Thank you for that elaborate answer. So, next question: is it possible to inject one sample in two different columns using one inlet? And how can we connect those both columns?
yeah, it is possible. Yes, there are applications also in some applications. We can connect the two columns in series using a capillary flow technologies or the press fit connectors. detectors. For one of very for R&D purpose and you don't use it regularly, then you can use a press fit technology where the glass fit will come to connect two columns in series or parallel. So in series means you connect the one column from the detector, and then in the outlet side you put that press fit and then connect another column from there and then to the detector. So generally we use it polar and mid-polar or mid-polar and non-polar chemistries together for the certain applications. From one inlet to one detector. When it comes to the one inlet to two detectors also possible, where the sample goes from one inlet, it splits and then goes to the two detectors. That is also possible. In these cases, I would recommend to use capillary flow technology, the metal connectors, so that it will splitting and all will be controlled pneumatically, so it will be uniform splitting. Or for a normal testing purpose you want it to do during your method development or optimization to see screen for a one or two runs for a particular sample, then you can use there also to Y split test. But when you are connecting it, you need an empty capillary. So empty capillary you will install in the inlet side from the inlet, and then at the end of the 1 or 2 meters you will install the empty capillary. There you will connect your splitter, and then from that splitter it will go to two columns parallelly, so that it will go to the two detectors. So both are possible. And remember, when you are connecting this, recommendable is capillary flow metal connectors, capillary flow technology connectors, and use of those will help you leak free. And use metal petals. Gold petals are recommendable due to its inertness, because when you are using two different chemistries, you are trying to see the both polar and non-polar or mid-polar together. In those cases, the active compounds might be there, so to address that, better to use the metal petals to connect it, gold metal petals. Yes, yes.
Okay, thanks, Ram. So the next question is, so we have these gas traps. So what do you recommend, like for the frequency of changing? How often do we change these gas traps?
Gas traps, there are two ways of looking into it. Better to have a color changeable gas traps, so that indicator glass traps after your universal big traps. Generally, if you don't have that, you will never know that whether my gas trap is saturated or getting a clean gas or not. That's the reason it is always advisable to have the color indicating gas trap just before your instrument or onto your car. As soon as the color has changed, generally it will be changes from greenish shade to the gray or black shade. So as soon as it got shaded from that color, then obviously it is an indication that the gas is not pure enough. So we need to change the gas trap immediately. Always advisable to use color indicating gas traps to get a desired result and without having any problems in our day-to-day operations. Big traps are good for the line which is in that one, but the traps are highly recommendable to have an indication whether am I getting a good gas or not. If the gas trap frequency changing is increasing, that means it's an also indicator for us. My universal big trap without an indicator, the big silver stainless steel traps will come. Those are already saturated, so we need to change that. So that will help you to have a good gas quality.
Okay, thank you, Ram. Another question is, so we have a gas flow meter. Can we use it as for leak detection as well? And what is the frequency of calibration that is required?
Yes, as we see, same central device. Actually, one main device is the same. Only cartridges will be changed. So you can use the same device for the gas flow as well as a leak detection. So for a gas, only the cartridge will be there. For a flow, ADM flow cartridge will be installed with the same device, and then detect your gas flow, measure your gas flow. And this flow cartridge will be a calibration is required. 1 year is the period from the date of installation, not from the date of procurement. As soon as you install into that one, that day it will start the meter for the particular cartridge. Once the 1 year is over, it automatically shows on the meter itself, the display. So calibration is over. So you need to re-install a new cartridge, need to be procured and installed. You don't need to send the main device to anywhere else for the calibration. The same main device, if you put the leak detection cartridge, so you can install that in the same thing, removing your flow cartridge, you put a leak cartridge and then detect your leaks. For the leak, you don't require any calibration, so there is no calibration is required for that. So you can use it until the cartridge spoils works.
Okay, thanks, Ram. I would request the participants, like this is a chance you have got to clear your like doubts, or you have any queries. I would request you please put your questions in the Q&A box. And Ram, the next question is, how are polar and non-polar columns different?
Yes. There are, generally, you might be using a DB1 or a DB5 column in your applications, which are non-polar columns. Wax column is a polar because one is polyethylene glycol, stationary phase, based stationary phase. So that is wax column. And another one is, for a non-polar analytes, you need a non-polar stationary phase. If it is a polar analyte, we need a polar stationary phase. For any chromatography separations, if you look into the carefully, the selection of the column is like this. For non-polar analytes, non-polar stationary phase. For polar stationary phase, analytes, polar stationary phase. But when you go to the ion exchange again, it's the same thing for LC also. So for ion exchange, whatever the ion you have, for a positive charged ions, we need a negative charge stationary phase. So not to get a confusion, we say that you have a cation, you take a cation exchange column. That means literally you will have a negative charge stationary phase. So that's the difference basically. The chemistry is polar in nature for polar columns, non-polar in nature for the non-polar columns. Like DB5, 5% phenyl polysiloxane. So basically polysiloxane is the base material for non-polar, and polyethylene glycol is the base material for the polar columns, like in wax column, for example. That's the difference. And in addition to it, if you say 6-4 chemistry, 6% cyanopropyl. So with the name itself, you can identify cyanopropyl is a highly polar in nature, so it's a bit polar column. Polyethylene glycol. Glycols are polar in nature, so stationary phase of wax column is polyethylene glycol is a highly polar chemistry. Non-polar polysiloxane, 100% dimethyl polysiloxane, DB1 column, polysiloxane. It's a non-polar in nature, so obviously it is for non-polar elements.
Thank you, Ram. So the next question is regarding the most commonly used consumable for the GC, that is the syringe. So what do you recommend? Like, what is the minimum volume which we can inject in the syringe? For example, it is a 10 microliter syringe. What is the minimum volume we can inject in from it, or the maximum volume we can inject?
Generally, each syringe have their minimal limitations. You need to see that carefully, because let's say that you have you installed 25 microliter syringe. Okay, roughly. Now you are injecting a 5 or a 10 microliter injection, and everything is perfect. And we don't focus on that actually. Then the next samples or a next different application, you wanted to inject a 1 microliter. And 25 microliter syringe barrel with a 1 microliter injection volume, you can imagine what will happen. this is where each syringe have their tolerance limit based on that. So for 10 microliter syringe, 1 microliter, not a big issue, more or less, and you can inject 1 microliter also. Let's say you wanted to inject 0.5 microliter, 0.2 microliters. Then 10 microliter is questionable again. For a general application, you may not see the impact, but the high viscous samples or the samples with very high active compounds in it, then you see this mismatches. That's where you need to go down to 5 microliter. So that's where you need to see that spec. Okay, what is the minimum injection limit? My volume of the syringe barrel is high. That's a 50 microliter, 25 microliter. I wanted to use it with 1 microliter injection volume. Then your precision is a question mark. So it will eventually influence your area of results. Yes.
Yeah, thank you. Thank you. So one more question is, can I do aqueous injections?
Aqueous injections?
On GC.
Yes. Whatever sample containing the water, you can do. Only the remembering, major important thing is to remember is when you are doing aqueous injections, you need a bonded and cross-linked stationary phase columns. If it is the stationary phase is non-bonded and not cross-linked, then the column degrades very, very fast. So when you are buying it, you need to see that whatever the column you are using, it may not be suitable for you. So if it is not a cross-linked and bonded and cross-linked stationary phase, so use that one. And the second important thing is when you are using a water as a sample solver. Let's say your application is demanding for some XYZ reasons, you need to be careful about the expansion volume after injecting the sample into the inlet and the liner one. How much the volume capacity of the liner and what is the expansion of my water at that particular temperature. If it is beyond, you try to reduce that. And then glass will also impacts majorly the results when you are using a water, because it's a very challenging for the most of the people when you have water in the sample, because of these are the reasons. And the glass wool is there, and any moisture or then the glass water particles are trapped inside the glass wool or the liner, then eventually it will influence the results, peak shapes and the peak areas of your polar analytes or active polar analytes. So you need to be careful about that, and you need to be carefully monitor the temperatures what you are using, and that temperature should be enough to flush out any of the moisture or the water particles due to the water as a sample source.
Thank you, ma'am. Thank you for answering all questions very patiently. I will just take one more question since we are just crossed the hour also. So the last question is, okay, we want to do the analysis of around 50 plus paints. So which column do you recommend?
Can you repeat it?
They want to do the analysis of paints, 50 plus paints. So
Okay.
yeah, what column?
Okay. If it is a female, generally 36, 37 is the method as per that. If you are looking for more than that, I would recommend HP88 chemistry with 100 meters length, because the number of tips are very high, and you are looking for cis-trans isomers and all clear separations. 100 meters length HP88 chemistry or CPCL88 for tips. But remember, better to have 100 meters length if you are looking for more number of frames. If it is less, then you can use fast frame or you can select frame columns directly, which will help you to get your frame analysis done.
Ram, one more question, just one more question. Can liners be reused?
Liners can be reused if it is not not contaminated or accumulated any of the sample. If it is contaminated, I would recommend don't reuse it for a critical applications, especially highly basic compounds analysis, amines analysis, sulfur compounds analysis, or acids and formic acid or acetic acid analysis will be done in the pharma industry. That also. And if it is without a liner, yes, you can try to solvent rinse and use it. You can use it. If it is a glass wool liner, I don't recommend to use it for the highly active and polar compounds analysis.
Okay, thank you so much. Thank you, Ram, for answering all the questions very elaborately and very patiently. And so that's all for today. Whatever questions we have, we will answer them separately by email. And thank you very much. Thank you everyone for joining these sessions, and we hope to see you in our next consecutive sessions for session on 12th for spectroscopy supplies. Thank you.
Thank you, Rajni, and thanks to all the participants who are attending this session. Hopefully it is useful for you and informative. Thank you. Over to you, Tejas.
Thank you, Tejas. We can close.